What is the basic difference between the stream cipher as well as block cipher? So definitely both techniques we have to convert the plain text to cipher text only. So but here based on the confidentiality we can able to apply the huge amount of data you have to. So the main intention behind the block cipher is the huge amount of message you have to sending from source to destination. So definitely you have to utilize the block cipher the methodologies, right? So here in that string cipher method, so the multiple techniques you have to follow. You can able to convert the plain text to ciphertext. That is, the ciphertext is called as the confidential informations, right? So in that, the multiple techniques you have to follow. That is called as the Caesar cipher or Hill cipher or substitution methods you have to follow. Transposition methods you have to follow. You can able to convert the so bit by bit or character by character how to convert it from the plain text to ciphertext in that the string cipher methodologies, right? So next, the one more. So that is the block cipher method. The completely different than the stream cipher to the block cipher. So in that block cipher, the main intention is the entire the message you have to divide into multiple the equal size of blocks. So each and every block that is the equal size of the remaining block. The complete message you have to divide into multiple the blocks. So here the block is considered as the input of plain text. So whatever the size, that is the 16 bits or 32 bits or 64 bits or 128 bits, whatever it is. So definitely each and every blocks you have to convert to the plain text to ciphertext. So whatever the input, the plain text you have to given, definitely you have to expect the same size of output in the receiver side. You already know. So in that sender, you have to convert the plain text to ciphertext in the sender side. So automatically there is the encryption policies you have to apply. The encrypt the plain text, you can get the ciphertext. Ciphertext is called as the secret information as well as confidential information. You can passing through the communication channel. Finally, in the receiver end, you can able to convert the ciphertext to the plain text. That is called as that is the decryption policies you have to apply. Finally, how to achieve the correct the message or the plain text will be received to the receiver. Yes or no? So in that block cipher method, definitely. So what are the basic principles you have to follow? You can able to convert the plain text to ciphertext in that block cipher methods. So first you have to divide the entire. So what are the steps you have to follow in that block cipher main principles, right? So first you have to divide the entire the message into the multiple equal size blocks, and next you have to identify the input block, and you have to convert. You can able to. So what about the block size? And you have to convert the block size plain text to ciphertext method. So what are the general the structures you have to follow? You can able to convert the plain text blocks to ciphertext block. So here that is the feature structure or feature structures you have to follow. You can able to convert the plain text to ciphertext in that block cipher method. So what it explains. So in that feature structures you have to follow the completely. So whatever the message you have to given, the multiple blocks you have to divide. So first, whatever the block you have to consider. So in that particular block, you have to divide into two equal parts. That is the two equal parts. So left part and right part. So here, so automatically you have to consider, for example, you have to consider 32-bit size of block size. 16-bit is the left side box, that is the 2 bytes of information, and 2 bytes of information. So here 8 bits will be considered as a 1 byte, right? So 1 byte, 2 bytes of information will be stored in that left side box, and 2 bytes of information will be stored in that right side box. And so here, so one more is that is the round function you have to apply. So where you have to apply the round function, so whether it is the left side or right side. The first in that feature structures explains. So only you can able to apply the round function in that right side itself only. So once you have to apply the round function in that round function, what are the round function? So which key you have to utilize? What size of keys you have to utilize to encrypt the information? So that will be performed in that right part itself only. Then you have to exclusive OR with the left part. So finally, we can get the certain results. So next we have to apply the swapping condition. You have to apply it. You can able to exchange the information. The left to the right box we have to store it. What are the results in the left side? That will be stored in the right side. And the right side result, so as usual, the same results we have to forward to the left side direction. So that is the completely the 4 steps you have to consider as a one round you have to finish it, right? So until we have to reach the n number of rounds, finally we have to get the ciphertext by the feature structure steps you have to follow. So that is depends upon the rounds. So what about the key size, the number of rounds? So what about the key size and the number of rounds and round function you have to consider as a the relevant the the relevant security of the relevant block cipher algorithm will be increased or decreased. So whether the algorithm is perfectly executed or not. So whether the algorithm is the most suitable for the information security. So it is, so though the number of critical the rounds you have to perform in that particular operation, so automatically that will be confidential will be increased. అంతే కదమ్మా. సో డెఫినెట్ గా సో డైరెక్ట్ గా ఆ రూమ్ లో ఉంది వస్తువు అనే దానికి ఆ రూమ్ లో పోతే ఇంకో రూమ్ ఇన్ఫర్మేషన్ వస్తుంది, ఆ రూమ్ లో ఇంకో ట్రెజర్ అంటున్నా. ట్రెజర్ అనేది హౌ టు ఫైండ్ ద ట్రెజర్. సో ట్రెజర్ అనేది ఈజీగా దొరికిపోతుంది. దాని ట్రెజర్ అంటే ఎట్లా అంటారు? సో దానికి సమ్ క్లూస్ యూ హ్యావ్ టు గివెన్. యూ కెన్ ఏబుల్ టు ఇంక్రీజ్ ద క్లూస్. క్లూస్ అనేది ఎక్కువ ఇచ్చే కొంది కాన్ఫిడెన్స్ తగ్గుతుంది. క్లూస్ ఎక్కువ ఇవ్వకూడదు, టఫ్ గా ఉండాలి అది. ఆ క్లూ అనేది కూడా చాలా టఫ్ గా ఉంటుంది. యూ కెన్ ఏబుల్ టు ఇంక్రీజ్ ద టఫ్ ఫర్ ద రిలవెంట్ క్లూస్. సో ఆ క్లూస్ కూడా మనం టఫ్ చేస్తా ఉన్నాం అనుకోండి, ఆటోమేటిక్ గెట్ ద కాన్ఫిడెన్షియల్ విల్ బి ఇంక్రీజ్. సో అందరికి ఆ రూమ్ లో ఉంది సో మోర్ వాల్యుబుల్ థింగ్ అనేది ఆ రూమ్ లో ఉందనగా ఈజీగా అందరూ దానికి తాళంగలం ఏం లేదనుకోండి, డెఫినెట్లీ ఈజీలీ యూ కెన్ ఏబుల్ టు ఎంటర్ అండ్ యూ హావ్ టు టోల్ ద రిలవెంట్ వాల్యుబుల్ థింగ్. అంతేనే కదా. సో ఆటోమేటిక్ హావ్ టు అప్లై ద లాక్. ఆ లాక్ లో పోతే మళ్ళీ ఇంకో సబ్ లాకర్ ఒకటి, గోద్రేజ్ లాకర్ ఒకటి పెట్టేసి దానికి ఒక సీక్రెట్ పాస్వర్డ్ పెట్టేసేసి, సో ఆ పాస్వర్డ్ కూడా కాంబినేషన్ కూడా తెలియకుండా బయోమెట్రిక్ పాస్వర్డ్ కూడా డిక్రిప్ట్ చేద్దాం అనుకోండి. ఫర్ ఎగ్జాంపుల్ 4 కాంబినేషన్ ప్రాబిలిటీ పెట్టేసుకొని, ఓకే సో అమ్మాయి డేట్ ఆఫ్ బర్త్ పెట్టుకొని ఉంటుంది, సో డేట్ ఆఫ్ బర్త్ పెట్టచ్చు. లేకుంటే ఆ ఇయర్, సో బర్త్ ఇయర్ మాత్రం పెట్టుకొని ఉంటారు, లేకుంటే 1 2 3 4 పెట్టేసుకుంటాం. సో సమ్ ద ట్రైల్ అండ్ ఎర్రర్స్ యూ హ్యావ్ టు పర్ఫార్మ్. కొంతమంది చేస్తారు కదా, 4 డిజిట్ నెంబరే కదా, 4 ప్రాబిలిటీ కొట్టేసి 4 ఫ్యాక్టరీలు కొట్టేసి దాన్ని కూడా ప్రాబిలిటీ చేస్తారు. డైలీ 2 3 టైమ్స్ చేస్తాం అనుకో, ఒక 1 year 2 year కి అది బ్రేక్ చేయొచ్చు. ఇట్స్ నాట్ ఎ ప్రాబ్లం. సో టు అవాయిడ్ దట్ సిచ్యువేషన్ డెఫినెట్లీ హ్యావ్ టు ఇంక్రీజ్ ద సో ప్రొటెక్షన్. సమ్ మెకానిజమ్స్ యూ హ్యావ్ టు అప్లై. సో ఆ కీ బదులు ఫామ్ రికగ్నేషన్, బయోమెట్రిక్ రికగ్నేషన్, లేకుంటే కంప్లీట్ గా రెటినా స్కాన్, ఫేషియల్ రికగ్నేషన్, వాయిస్ రికగ్నేషన్, మల్టిపుల్ కాంబినేషన్. ఫస్ట్ లెవెల్లో కీ ఎంటర్ చేస్తాం, ఒక డోర్ వస్తుంది. సో నెక్స్ట్ లెవెల్లో ఫామ్ రికగ్నేషన్ కంప్లీట్ గా మన రైట్ హ్యాండ్ మొత్తం పెడితే మాత్రం ఓపెన్ అవుతుంది అనమాట. కొన్ని మీరు హాలీవుడ్ మూవీస్ చూస్తే ఉంటారు మీరు. సో సెక్యూరిటీ డిఫెన్స్ అకాడమిక్స్ లో వాళ్ళు ఎంటర్ అయ్యేటప్పుడు చూడండి, ఫస్ట్ రెటినా స్కాన్ చేస్తారు, లోపలికి మళ్ళీ ఫామ్ స్కాన్ చేస్తారు, మళ్ళీ లోపల పోయినాక వాయిస్ రికగ్నేషన్ ఇస్తారు. సో కంప్లీట్ గా మళ్ళీ ఇంకా అది కూడా దాటుకొని లోపలికి వెళ్ళారనుకోండి, దాని లోపల ఒక లేజర్ బీమ్ ఒకటి ఉంటుంది అనమాట. సో దాంట్లో అనదరైజ్ పర్సన్ ఎంటర్ అయ్యారనుకోండి, డైరెక్ట్ కట్ అయిపోద్ది బాడీతో పాటు లేజర్. సో లేజర్ హై పెనట్రేషన్ లేజర్ బీమ్ అనేది ప్రొటెక్ట్ చేస్తారు అనమాట. సో కొన్ని డైమండ్స్ అలాంటివి పెట్టినప్పుడు చూసింటారు కదా మీరు ధూమ్ సినిమా చూసారా? ధూమ్ లో ఒక డైమండ్ రాబరీ అనేది దాంట్లో మళ్ళీ లేజర్ బీమ్ కూడా ఉంటుంది అనమాట. సో దాన్ని ఏమైనా అలారం సో బ్లో అవడం, లేకుంటే బై హ్యూమన్ ఏదైనా థింగ్ చేసినప్పుడు కట్ అయిపోవడం ఏదో జరుగుతూ ఉంటుంది అనమాట ఇవన్నీ కూడా. సో అట్లా మల్టిపుల్. సో ఆథరైజ్డ్ పర్సన్ కి ఆ లేజర్ బీమ్ ఎట్లా స్టాప్ చేయాలో, ఎట్లా ఎనేబుల్ చేయాలో, డిజేబుల్ చేయాలో వాళ్ళకి తెలుసు అనమాట అవన్నీ కూడా. సో యూ కెన్ ఏబుల్ టు ప్రొటెక్ట్ ద unauthorized access అనమాట. సో ఇన్ ద సేమ్ వే you can able to in that the block cipher methodologies, you can able to increase the protection. Definitely you have to increase the key size, so increase the number of rounds. So you can able to the confidential, you can able to critical operations how to perform in that round function. So that is the basic parameters you have to consider in able to protect our the information more secure to transfer from source to destination. So last class we already discussed about so one of the block cipher algorithm that is called as the DS algorithm, data encryption standard. So what are the basic the points you have to discuss in the DS algorithm? So what about the block diagram? So what about the key size? What about the input plain size, text size? What about the round function? So what are the relevant steps you have to follow? So first the basic point in the DS algorithm, that is the data encryption standard. So what about the input plain text, the block size is also is belongs to the block cipher method. So completely the entire the message you have to divide into so multiple blocks. So here also each and every block you have to convert into the plain text to cipher text method. So better to note down the AES algorithm. So here, so normally, so 1 byte equal to 8 bits. So what about the 1 word equal to 4 bytes or 32 bits? Yes or no? 4 bytes equal to 1 word equal to 32 bits. So here, so in that AES algorithm, so the confidentially, so in the sense of DES algorithm, is strictly follow the bytes formation. Here the words formation. The totally the 128 bits we consider as a 4 words. Antena kada? So 32, 32, 32, 32. So 1 word equal to or 16 bytes. Yes or no? The same, the output also, the 4 words or 16 bytes. So here, each and every round, you have to utilize the 4 words of information. So based on the key size also, so 128 bits are the 4 words. So by the key, you have to produce the 44, the sub keys you have to generate it. So here, how to generate the sub keys, it will be discussed later. So here, this is the general, the information about AES algorithm. So AES algorithm also, so one of the block cipher method. In that AES algorithm, you have to, the input block size is 128 bits, and so output also you can able to, that is the output is called as, this is the input is the plain text. So output also you can able to 4 words or 16 bytes. So that is called as cipher text. So here the output also you can able to produce the same size of input text size. అంతే కదా 128 మనం ఇచ్చాం 128 output మనకు రావాలి. So that is called as the cipher text. So here in that information security, in that network security model, the input is the plain text and output is cipher text, right? So in that key size also 128 bit and the number of rounds equal to 10. So in the DES algorithm, the number of rounds equal to 16. So in that AES also, AES algorithm, so most upgradation will be happen. So that will be increase the key size. Definitely you have to increase the number of rounds. So better to observe this in this diagram. So this is the block diagram of so better. So online students, so better see in screen sharing. So in that block diagram, so here, so n number of rounds, that is depends upon the key size. So in case 128 bits, you have to consider that is the 10 rounds. And so in case of 12 rounds, that will be considered as a 192 bit key size. And it will be able to increase the number of rounds 14, that is the 256. So here the key size and number of rounds will be increased, definitely increase the security also. So in that each and every round you have to follow the same procedure, right? So in that block diagram, so better to observe. So this is the, so for example, you are considered as a 128 bit cipher text, that is called as only the 10 rounds will be happen. So the input plain text, so in the diagrams better to observe. So 128 bit plain text you have to given, the round keys you have to utilize, that is the K0 to K9. So because totally 10 rounds. In that, for example, you have to given the key size of 128 bit. So plain text also 128 bit, the equal size of plain text you have to consider. So based on key size, right? So the entire the key, the expansion, so key expansion, that is the multiple combinations you have to produce, the randomly how to choose the out of 128, you have to randomly how to collect the keys, you have to generate the 10 sub keys you have to generate it. So each and every key you have to generate, you have to pick the words of keys information, you have to exclusive or with the plain text box each and every round, and the right shift operation you have to perform, and the so mixed column operation you have to perform that each and every round. So next we go for the round function. So what is happening in that each and every round, that is the general block diagram of AES algorithm. So better to note down all the diagrams. So all of you, so better to note down AES block diagram first. So what are the key points in AES algorithm? So what about the input plain text size? So what about the number of rounds, and what about the key size, and what about the round function, right? So next we go for the what about the block diagram of AES algorithm. That is the block diagram of AES algorithm. In that one, we can able to choose the 10 rounds concept. So why? Because you can able to utilize 128-bit plain text, that is the input side, and you can able to apply the 128-bit key. So that's why you can provide the only 10 rounds we have to perform. So here the next we go for, so what is happening in each and every round. Okay, not just another. So here, so better to understand, so what is the general, the procedure will be involved in that AES algorithm. So that is the in Advanced Encryption Standard. So that is the one of the best methodologies you have to follow in able to convert the plain text to ciphertext block. This is also one type of the block cipher method. And here the first step is, what about the block size? The first, so these are the things మీరు దాంట్లో X boxes, substitution boxes, matrix formation, 16x16 matrix formation, మిక్స్డ్ కాలమ్స్ ప్లస్ షిఫ్ట్ రోస్, రైట్ షిఫ్ట్ లెఫ్ట్ షిఫ్ట్ బైట్స్ కన్వర్షన్, అవన్నీ రాయాలంటే ఒక 10 to 12 hours పడుతుంది ఎగ్జామ్ లో. అవన్నీ అవసరం లేదు, యు జస్ట్ రైట్ డౌన్. సో వాట్ ఆర్ ద ప్రొసీజర్? సో basic points, what about the diagram for the AES algorithm? So what about the plain text size? So what are the block size? And what about the key size? So what about the round function? So how many number of rounds will be happen in that AES algorithm, each and every round? So what are the techniques you have to follow? You can able to convert the plain text to ciphertext, right? Until you have to reach the n number of rounds in that particular AES algorithm. So here, basically, you can able to consider as the 128-bit is the plain text block size. So 128-bit is called as the 16 bytes or 4 words. So 4 words, that is the one word equal 32 bits into 4 into 32 is equal to, so 128, 64 plus 64. Antena kada? So that is the 16 bytes. 16 into 8 equal to 128 bits. 128 bits or 16 bytes or 4 words. That is the plain text size. That is called as the plain text block size. And so here the n number of rounds is, so why? Because here the block size, input block size is 128 bits. So that's why you can able to choose the 128-bit key size also. The same key size you have to utilize, you have to convert the plain text to ciphertext, right? So that is the, here also based on the key size, you can able to choose the number of rounds. So for example, in the diagrams, better to observe the number of rounds, that is the R count will be increased based on key size will be increased. So here in this diagram, we have to consider only 128 bits input plain text. That's why you have to choose the 10 rounds only. So round 1 to and from round 10. So our point is, see here, so what are the round operations you have to perform? The first you have to identify the key. So key you have to consider, that is the 128 bits, that is the 4 words bits you have to combination, you have to produce, that is the 16 by 16 combinations you have to produce, and you have to generate the 44 sub keys you have to utilize, that is the 44 words we have to consider, 32 bits you have to consider. We can able to randomly how to choose the, చూడమ్మా మనం ఎన్క్రిప్ట్ చేయాలంటే the plain text and key size కామన్ గా ఉండాలి. ఇక్కడ మనకి 44 వర్డ్స్ వస్తున్నాయి. మనకి 44 వర్డ్స్ మీన్స్ the 4 words is equal to 128 bits. అంతేనా కదా? మనం 4 వర్డ్ plain text తో 4 words key తో మనం ఎన్క్రిప్ట్ చేయాలి. You can able to randomly how to choose the 44 sub words you have to consider. అంటే 44 divided by 4 equal to 11 వస్తాయి ఇక్కడ. సో మీకు కన్ఫ్యూజన్ రావచ్చు, సార్ మనకు ఉండేది 10 రౌండ్స్ ఏను, మీరు 11 సబ్ కీస్ 11 కాంబినేషన్ లో చూపిస్తాను అంటున్నారు. సో బట్ హియర్, సో దట్ ఈస్ ద ప్రీ రౌండ్స్ విల్ బి హ్యాపెన్ ఇన్ దట్ AES algorithm. సో దిస్ ఇస్ అ వెరీ ఇంపార్టెంట్ కాన్సెప్ట్. సో యాక్చువల్లీ ద 10 rounds, 10 into 4 equal to 40 words is enough. That 40 the sub keys is enough to encrypt the each and every round for the plain text message. So but here you have to divide the entire the keys, you have to divide into 44 sub keys you have to generate it. The 4 words will be utilized for the pre round transformation. Pre round transformation means you have to exchange the sum of the columns, you have to mix it with the another column. That is the first, that is the pre round transfer you have to perform. So in that purpose you have to use the k0 value. So here the totally the k10, that is the totally k0 to k10 means, so totally the 11 the keys you have to generate it. So each and every key that consists of the 4 words. That is the pre-round operation you have to perform in the AES algorithm. That is the one round you have to consider. So that is the pre-round, so not countable. The next one is the total number of rounds. Meeru bits multiple choice point of view lo how many number of rounds in AES algorithm and so based on 128 text input size anna anukondi 10 rounds ani maatrame cheppali. So one of the pre round will be not considered. So first we have to exclusive OR with the key to the in pre round operation. Some exclusive operation we have to perform the shift rows, that is depends upon the techniques you have to follow. The randomly you have to choose a certain operation. So that is the pre-round operation is over. The next we can go for the add round key. That is the K naught. That is the pre-round operation we have to perform. We can able to add the key to the existing plain text of 128 bit, and we can go for the first round. In that round, so what are the sub operation will be happening in that round one function. So that is the in that substitute bytes and the shift rows operation and mixed column operation. Here also better to observe. So the three sub operations we have to perform that each and every round. ఒక్కొక్క round లో ఈ 3 operations జరుగుతాయి అన్నమాట. Next we can go for the second round until we have to reach the 10 rounds. ఇక్కడ చూడమ్మా. So one more important concept. So important point. The first round to 9 rounds, 9th round up to 9th round. First round to 9th round, the mixed column operation will be performed in that first round to 9th round. So but in 10th round, out of 3 operations, the mixed column operation will be not performed in the 10th round. 10th round lo mixed column operations ani cheyalsina avasaram ledhu. That is also very important concept. Right? So that is the round operation. So what about the substitute bytes? That is the S box bytes. So automatically that is the 16 by 16 combination, or we can able to perform the some matrix representation we have to perform. So that is the input, that is the 4 by 4 we have to consider each and every. So box will be considered as a 4 bytes of operation. So that is the I00 and I10, so I20, so that is why the totally that is the input 128 bits will be divided into 4 by 4 the matrices representation, and output also produced the same size of the matrix. So that is the output of 00, so 10 and 20 and output of 30, and so on. We are able to raise the output of 3 by 3, so input of 3 by 3. So antena kada. So next, so automatically we have the substitution we have to happen. We can able to substitute with so 1 byte by another byte. So here the totally so 2 bits, so 4 bytes will be happen in that each and every the box. So 4 bytes is considered as a 4 bytes is considered as a one word. So definitely, so we can able to substitute with bytes. Ikkada first round lo we can able to substitute with so 1 byte by another byte. We can able to key we have to combine. So key to మనం substitute చేయాలి. So next we can go for the shift rows operation. That is the shift right operation. So arithmetic shift right operation. So maybe the first column there is the 1 bit we have to shift right operation. It already SEO lo వచ్చుంటది ఇదన్నీ కూడా. Boost algorithm something మీకు వచ్చుంటాయి. So boost algorithm lo how to perform the shift circular shift right operation. So first column will be considered as a 1, the bit we have to forward to the right side. That is the circular right shift operation we have to perform. And so next one is the mixed column, means we can able to multiply with so one row to another column. We have to multiply with the plain text is the plain text input. So that is the key you have to some generated, that is the K01. ఇక్కడ మనము సో 4 by 4 key తీసుకోవాలి, 4 by 4 input text తీసుకోవాలి. దీంతో మనము సో మిక్స్డ్ కాలమ్ లో సబ్స్టిట్యూషన్ ఇవన్నీ చేస్తాం. So one round is finished. That is the particular the mixed column, means we have to convert, we have to multiply with K. First ఇది substitute byte చేస్తాం, next shift rows చేస్తాం. So next mixed column with multiply with the key to input message. చేసిన తర్వాత వచ్చిన రిజల్ట్ ని you can able to same you have to forward to the next round, and second round is complete, we can forward to the result to the third round. So next fourth round until you have to reach the 9th round. So 9th round వరకు ఈ మూడు ఆపరేషన్ చేయాలి. So finally in the 10th round, except the mixed column operation, the remaining all operation will be performed. So finally you have to produce the result of the 4 by 4 bytes, that is the 16 by 16 combination you have to produce. That is the output of so 128 bits output cipher text. That is we can able to perform the output. So, right? So output you have to produce, that is the 128 bits of output cipher text you have to produce after getting the completion of successful completion over the 10 rounds. అర్థమవుతుందా? ఈ ప్రొసెసర్ రాస్తే సరిపోతుంది. మీరు అక్కడ మ్యాట్రిక్స్ మల్టిప్లికేషన్స్ అవన్నీ 4/5 మ్యాట్రిక్స్ మల్టిప్లికేషన్స్ అవన్నీ చేస్తాం, మనం ఏం కూర్చోబడలేడ. సో వాట్ ఆర్ ద ప్రొసెసర్ ఇన్ దట్ కేస్ బ్లైండ్ గా మీకు